Bum, 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 ba-bum, bum, 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 bum. For those of you who have seen this movie, my sympathies go out to you. Although it is part of American culture. I mean, back in the 70s, this movie was a big deal, and I forced my wife to watch it. Actually, it took 3 tries, and she hated me for it. Let's talk about the ACT exam. We have a bunch of students and they take the ACT exam and then they go through an ACT prep course, which is designed to increase their score. We're not asking the question, did the course increase their score? It should be that every time you take the ACT exam, your score goes up a little bit. I mean, practice and whatever else. We want a confidence interval for how much did their score increase based on the fact they took this prep exam and it's the second time taking the test. Now, this is a matched pairs scenario. How do you know that? Not because it's written at the top of the board. I realize that I wrote that on the top of the board, which totally ruins the question. But on an exam, it doesn't say matched pairs confidence interval at the top. You have to be able to identify that this is a matched pairs scenario. So how would you do it? Well, you would try to think to yourself about the data. What would the data look like? Well, we would have the first person say Adam and his before and after score, and then Betty, her before and after score, Carl, before and after, and you have Debbie, and then you have Eric, and then you have a girl's name that starts with F. How about Francesca? And for each of these, you would have a before and after score. Well, could I take Adam's second score and Betty's second score and swap them? Would it matter? The answer is it would matter because Adam's before and after are linked to Adam. They are matched by being from the same person, matched by person. And so you wouldn't switch the data. You want to do this as matched pairs. And here's the reason this is such an important deal. Imagine if Betty's really smart and her ACT scores were high. And let's say Eric is struggling and so his ACT scores were low. Betty's going to have a high before and after. We don't care. We just care about how much did it change. Eric's going to have a low before and after. But that doesn't matter. We just care about the change. So you can see the standard deviations here are big, but if we look at just the differences, our standard deviation is smaller. This is why matched pairs is such a powerful type of test. You get a smaller standard deviation because we've evened out who is really good and who is really bad. We just care about the differences. So let's think about our classic hypothesis test. How do we know it's a T instead of a Z? Well, these standard deviations are not magically known. They come from data. They come from those 6 students. And so because we have S instead of sigma, we're going to use a T-score. And because this is matched pairs, we want to remind ourselves which X-bar we're talking about. Are we talking about the X-bar before or the X-bar after? And the answer is neither. We're talking about the X-bar of the differences, which is why we put these annoying little D's on there, which the D's don't really do anything except try to remind you we're talking about matched pairs. If we were doing a hypothesis test, the mu that we would be interested in is 0. Because it's a confidence interval, I'm going to leave mu in this equation. And now I'm going to look at the differences. For the means, it's easy. I'm just going to subtract the means. They don't do anything tricky, which if I take 78 minus 89, I get negative 11. Does it matter whether it's positive or negative? The answer is no, as long as you can keep it straight. And in the homework, if you flip those around, it should be that the program knows that there's 2 possible answers, depending on whether you're taking after minus before or before minus after. The sample size is also easy. We're talking how many differences. We're comparing the differences for 6 students. So there's 6, the same as the before and the after. But the standard deviation is tricky. You're not going to get the standard deviation from the 7 or the 9. Those numbers are completely useless because it's matched pairs. The only way you could figure out the matched pair standard deviation is if you had the original data, which is why I wrote it right down here. I gave it to you in the problem. It's 4 because it said so. Now be warned, if it's not matched pairs, I might tell you a matched pair standard deviation too, because I want to see if you can spot when it's matched pairs based on the scenario. Now I have my values. All I need is to solve for mu so that I have my equation for the confidence interval, which should look exactly like what you expected it to. Our mu difference, don't get confused by the belongs to, it's just a math thing, you can't really put equals because it's a whole range, but there's our average, there's our t-score, standard deviation over square root of n. It's the same except for the annoying little d, which does nothing but remind you we're talking about a matched pair scenario here. So I can fill in the values. I need my t-score. Degrees of freedom are n minus 1, same as I'm used to, which would be 6 minus 1. So I'm going to put in my degrees of freedom, which are 5. And if I want 90% confidence interval, that means I have 10% in the tail, so 5% in each tail. You should be comfortable with that. If you're not, come talk to me. And with that, we can plug in our number and get our confidence interval. Don't be worried about the negative. The negative just tells you the before group was smaller. So before this prep class, your score was 14 to 7 points lower. If you worded it the other way after you took the class, then you would have a positive 11 and it would go 7.71 to 14.29. And the computer should be able to recognize that you can do it either way. You now are welcome to return back to your movie. Oh, you haven't missed anything, I promise.